Hi, this is my second lab report for my course and it's done on the following object. The physics that I used here is Newton's second law, which states that the final velocity is equals to the initial velocity plus the force, net force divided by mass times the time, or it is also can be stated as rate of change of momentum is directly proportional to the applied force. So the F net here is m times g, mass times the gravitational force, acceleration due to gravity, and plus there will be some drag force, so Vf will be varying. And the experimental data that I used is the mass of the ball is 0.03 kilogram, the total duration is 0.634, which I got from the tracker, and the total length is 1.77 meters. I recorded my video and inputted into the tracker, and I got the information of time as well as the negative y direction position. So the axis is set in the negative y direction, and as I run the tracker, as you can see, the ball is falling down and I got the time as well as the negative y position for my video. I use this information for for the model for the computer, and using those two information, those two data, I formed a graph which is, as you can see now, the blue line which is the experimental data and the red line which is the computer data, they are not matching other than the few initial conditions. This may be due to the drag which is there in the experimental data and that we have not inputted for the computer model. So I inputted the drag in the computer model, which the drag constant I use is 0.05, so that the final position of the computer model as well as the experimental model is same. As we can see in the graph also, there are few points which I got same as the computer model and the experimental model, but other than that there is a big variation in the experimental data. So I thought it may be due to the velocity, so I changed again the drag force and I inputted the velocity squared 1, for which I'm not pretty sure whether the equation that I use is right or wrong, because I took the equation from the forum that we were using. And as you can see, again, the final position of all the experimental data, the drag and also the drag with velocity squared data are same. For the last one, the velocity squared one, the green one, I used the constant b, which is 0.22, so that I get the final position same as the drag and the experimental model. But still again you can see there is a lot of big variations in the computer model, in the drag velocity squared model as well as the experimental model that I got. And I will show you the Python that I used, the equations that I used in the V module, and the ball mass 0.033, the ball position as well as the initial velocity and initial position, the acceleration due to gravity, which is 9.8 meter per second square, and here you can see I use the second one, b is equal to 0.022, the drag constant, and the time is 0.634 seconds. And here is the equation that I used, that I took from the PISA forum that we were using in the course, as I'm not aware of how to input the velocity squared equation in the Python. So I just copied it from there. Sorry for that thing. And the net force that we are using is W plus F into D, the drag force. And I run the module. So there will be two arrows, as you will be seeing it now. Yes, the yellow arrow which is pointing downward is the weight of the object, and the blue arrow which is becoming bigger and bigger, enlarging one, which is the drag force. Initially the drag force was very small, as it comes down the drag force increased. And the graph that you can see is the graph that I obtained for the, as I think it is a velocity squared one, and here is the time, and this one is the position that I got, the final position. So in conclusion, I can tell there will be error in my recording, the video recording, as well as the shape of the object may influence the drag, the experimental error, and so there is a lot of scope of improvement in my lab report. So a lot of suggestions are welcome. So how is the equation that I used for velocity square is right or wrong? I'm not aware. So please give suggestions in that case also. So thank you for watching my video.